Imagine looking up at the night sky, your gaze wandering across a sea of stars, when suddenly you spot a question mark etched into the cosmos itself. Yes, you read that right. A literal question mark hanging there among the galaxies. It almost feels like the universe itself is asking us something. Thanks to NASA's James Webb Space Telescope, this isn't just a whimsical thought experiment. Astronomers have actually observed a rare gravitational lensing phenomenon that looks startlingly like a cosmic question mark. It happened in the galaxy cluster known as Max J0416. This isn't just a pretty sight either. This particular event offers some deep insights into galaxy formation, evolution, and the mechanics of gravity in ways we've barely scratched the surface of. So, what is this mysterious cosmic question mark trying to tell us? Let's dig into what this discovery means, the science behind it, and why it matters more than you might think. First, we need to understand the concept of gravitational lensing, which is a lot less complicated than it sounds. Essentially, gravitational lensing occurs when a massive object, like a galaxy cluster, warps the space around it so intensely that it bends light coming from galaxies located behind it. This creates a kind of cosmic magnifying glass, distorting and magnifying the appearance of those faraway galaxies. Think of it like how a glass of water bends light to make a straw appear distorted. Now replace the water with the fabric of space itself, and that's gravitational lensing for you. In the case of the Max J0416 cluster, this cosmic lensing resulted in an image that, bizarrely, resembles a question mark. The hook of the question mark is a red, elongated galaxy, and the dot below is another galaxy. But here's the kicker. This specific arrangement, known as a hyperbolic umbilic gravitational lens, is incredibly rare. We're talking lottery-winning odds here. Only 3 or 4 such alignments have been observed in the entire universe so far. It's a bit like finding a 4-leaf clover, except the clover is a galaxy cluster billions of light years away, and the universe is holding it just right for us to see. This extraordinary alignment was captured by the JWST, and it's giving astronomers some unprecedented opportunities to study the galaxies involved. Unlike the Hubble Space Telescope, which primarily works in visible and ultraviolet light, the JWST operates in the infrared spectrum. This allows it to cut through cosmic dust, offering us a clearer, deeper look at these faraway galaxies. What makes this cosmic question mark so exciting is the interaction between 2 galaxies involved, a spiral galaxy seen face-on and a dusty red galaxy viewed from the side. This interaction is only just beginning, which is a huge deal for astronomers. We're basically getting a front-row seat to the start of a long and dramatic dance between these galaxies. When galaxies interact, they can merge, collide, or pass close enough to each other to be influenced gravitationally. This triggers some pretty spectacular cosmic fireworks, namely, bursts of star formation. The gas clouds within the galaxies get compressed and heated, sparking the birth of new stars. In the case of this lensed question mark, astronomers have already detected active star formation in compact regions within both galaxies, which means the gas between them is starting to collide and form new stars. But here's where things get even more interesting. Despite the gravitational interaction, neither galaxy appears to be significantly disrupted. That suggests we're seeing the very beginning of a process that will likely unfold over millions, if not billions, of years. This is like catching the opening act of a concert that will continue long after we're gone, and it offers us a rare glimpse into how galaxies begin to influence each other under the pull of gravity. Why do we care so much about where and how stars form? Well, understanding star formation is key to unraveling the evolutionary history of galaxies. Think of it like reading a family tree, except instead of branches and names, we have stars and cosmic interactions that stretch back billions of years. As astronomer Venti Estrada Carpenter from St. Mary's University explains, the details of star formation provide a clearer picture of a galaxy's development over time. In this case, the James Webb Space Telescope's NIRIS, near-infrared imager and slitless spectrograph, is an especially powerful tool. It's designed to detect star formation in galaxies that are billions of light years away. That's right, billions of light years. The Webb telescope confirmed that these two galaxies, the dusty red one and the face-on spiral, are, in fact, at the same distance, proving they're interacting. We're not just observing a cosmic optical illusion here. This is the real deal. By studying interactions like this, we're not just learning about some distant galaxies, we're learning about our own. About 7 billion years ago, galaxies like the ones in this question mark were undergoing rapid transformations, growing in size and forming new stars at an incredible pace. In fact, it's highly likely that our own Milky Way went through a similar phase, merging or interacting with other galaxies to become what it is today. By looking at these distant galaxies, we're essentially peeking into the teenage years of our own galactic home. Gravitational lensing isn't just some cool optical trick, it's a game changer in how we understand the universe. These cosmic magnifying glasses allow astronomers to study galaxies that would otherwise be too faint or too far away for us to observe. And sometimes, they create some really beautiful and downright strange visuals in the process. One famous example is the Einstein cross, where the light from a distant quasar is bent around a foreground galaxy, creating 4 distinct images arranged in a cross-like pattern. This isn't just a neat picture. It allows scientists to study the mass of the lensing galaxy and map out the distribution of dark matter within it. Then there's the Einstein ring, which occurs when a distant galaxy or star aligns perfectly with a massive object between it and us. The gravitational field of the intervening object bends the light into a nearly perfect ring. It's like looking through a keyhole into the farthest reaches of the universe. Another variation of this is the cosmic horseshoe, where the light bends into an elongated horseshoe shape. Both phenomena are invaluable for helping scientists map the mass distribution of galaxy clusters and understand how dark matter, the mysterious substance that makes up about 85% of the universe's mass, is spread across the cosmos. But perhaps the most fun example of gravitational lensing is the smiley face galaxy cluster. It looks exactly like it sounds. 2 bright galaxies form the eyes, and a distorted background galaxy creates a smile. While it may look whimsical, this phenomenon is yet another testament to how galaxy clusters warp space-time, bending light into familiar shapes. Here's where gravitational lensing gets even more critical. While we can see galaxies and stars with telescopes, dark matter doesn't emit, absorb, or reflect light. It's essentially invisible. So, how do we study it? Gravitational lensing gives us a workaround. By observing how the light from distant galaxies bends as it passes through massive objects, astronomers can infer the presence and distribution of dark matter. Without this invisible stuff, the lensing patterns would look completely different, and in some cases, they wouldn't exist at all. Each example of gravitational lensing, from the Einstein cross to our new cosmic question mark, acts as a natural telescope, giving us a window into the hidden structure and dynamics of the universe. And with every new discovery, we refine our models of how galaxies evolve, how dark matter behaves, and ultimately, how the universe itself is structured. So, what does this cosmic question mark mean for us, sitting here on our little blue planet, looking out into the depths of space? On one hand, it's a quirky coincidence, a question mark formed by galaxies billions of light years away. But on another, more profound level, it's a reminder of just how much we still don't know. The universe is constantly revealing new mysteries, and every discovery we make leads to even more questions. The cosmic question mark stands as a symbol of the endless curiosity that drives science forward. It's a testament to our never-ending quest to understand the universe, to map out its structure, and to unlock the secrets hidden within it. As we continue to observe and explore, there's no telling what the next chapter in our journey will reveal. But one thing is certain, the universe will keep asking questions, and we'll keep searching for the answers. Stay tuned, because the adventure is far from over. Who knows what other surprises are waiting for us out there among the stars?